I'm very pleased to be here today. And one of the things that seems to be a persistent and important theme throughout today has been the importance of collaboration, public-private partnerships, and really looking at how we can best work together to address some of our very important and critical problems. I'm going to be talking a little bit today about a public-private partnership in Tampa Bay that was initiated as part of work through our local governments and in the success that we've had with that. I'm calling this a recovering urban estuary because we have seen significant recovery in Tampa Bay, even though we've seen more than 1 million people come into our bay over the last 20 years. So in spite of this increasing urbanization, we've seen some very significant recovery. Some very quick facts about Tampa Bay. We're Florida's largest open water estuary. We're about 400 square miles. Nothing like Chesapeake Bay, but not a small one either. The average water depth is very shallow. It's only about 12 feet. We do have a major port. It's a port. Tampa Bay is one of the top 10 in the United States in terms of the amount of material that is shipped through the port. And a watershed population of about 2.3 million. Again, that has, when I started at the Estuary program about 25 years ago, we were at 1.3. So we have seen a tremendous urbanization just in the last 20 years. The red on this graphic shows the urbanized watershed elements of Tampa Bay. This is what Tampa Bay looked like in the 1970s. It was very polluted. Nitrogen pollution was the major source. Algae covered the surface of the water, and it was actually considered a poster child for nutrient pollution in the United States. It was so polluted that people were considering it dead. Lots of the algae was washing up on shorelines, and with very significant odor problems as well as just the problems in the bay itself. Half of Tampa Bay's seagrasses were lost between 1950 and 1982. Half of our natural shoreline was developed. 40% of our tidal marshes were destroyed. Some of our major bird populations that depend on Tampa Bay were reduced very significantly. Visibility was reduced to about 2 feet in some parts of our bay. So a very heavily polluted area in Tampa Bay. Again, it was considered a poster child and in fact was part of a 60-minute segment that brought national attention to nutrient pollution. And so it was definitely high on people's radar about how polluted it was. Another number, just like many of our coastal areas, poorly treated sewage, unrestricted dredging and filling, untreated stormwater runoff, and industrial discharge were primary causes to this decline, with a common pollutant being excess nutrients, primarily nitrogen in Tampa Bay. Restoring Tampa Bay started off with citizen action. It was the citizens that lived along the shoreline of Tampa Bay that said, we're not going to stand for this. Legislature, do something about this. And the Florida legislature did. In 1979, a bill was enacted, again, at the insistence of the citizens around Tampa Bay, only dealing with Tampa Bay, not any of the other areas in Florida, that required the wastewater treatment plants to implement advanced wastewater treatment within 3 years, or to go to 100% reuse within 3 years. And they were able to do that. There was, at the same time, there were monies from the Clean Water Act. So there were funds available and this requirement from the citizens through the legislature that really kick-started the recovery of Tampa Bay. Regulatory restrictions on wastewater in the early 1980s, again, through that legislation. State and local agencies enacted stormwater treatment in the mid-1980s. And then the Tampa Bay Estuary program sort of stood on the shoulders of all of this action that had been implemented and started in 1990 to continue the restoration efforts. The Tampa Bay Estuary program is one of 28 national estuary programs. around the United States, really focusing on partnerships and making sure that state, federal, and local partners are involved with developing a plan and implementing a plan to restore and protect our estuaries. One of the first things that the elected officials on our policy board did was to set a seagrass restoration goal of restoring seagrasses to 1950s levels. Again, that was a very aggressive goal. We had lost about half of our seagrasses by 1990, but they felt that this was a very strong goal, given that seagrass is a real cornerstone of the ecosystem in Tampa Bay. Through a series of research and modeling efforts, both mechanistic and empirical modeling, we were able to, once we had this seagrass restoration goal of 1950s levels, a numeric goal there, we took a look at seagrass light requirements, found that seagrass required about 22% light to the bottom. From that, we looked at light attenuation factors and came up with a numeric chlorophyll A concentration goal that is related to allowing seagrass to be recovered. And from that, again, through a series of modeling efforts, we're able to relate that chlorophyll goal, how much nitrogen could come into the bay and maintain that chlorophyll A concentration goal. So we now have numeric total nitrogen loading goals, as well as chlorophyll goals, seagrass light goals, and our ultimate goal, of course, is seagrass recovery. When our public partners that participate on the estuary program realized that nitrogen management goals were unattainable without private sector help, they invited the private sector to participate with them in a voluntary nitrogen management consortium. This happened in 1996. Each partner contributed to nitrogen management goals as they were able to do, the projects that they were able to do overall. There were no requirements or allocations at this point, but collectively they have reduced almost 600 tons of nitrogen per year. This public-private partnership, again, is a partnership of local governments, regulatory agencies, local phosphate companies, which is one of our major industries, agricultural interests, and electric utilities. A very big part of our nitrogen budget is atmospheric deposition, so having the electric utilities be a part of this overall plan was an important piece. Again, over 300 projects have been implemented between 1996 and 2013, a whole range of different types of activities reflecting the diversity of the partners in the Nitrogen Management Consortium. Through this process, our nitrogen loading has decreased significantly. In fact, we now have less than half of the nitrogen load coming into Tampa Bay that we did prior to 1980. You can also see that we see a big change in what our sources are. In the 1970s, more than half was from point sources, and non-point sources made up only about 16% at that time. After the wastewater treatment plants reduced their loadings, we now have non-point sources, which, as Nancy mentioned, are much more difficult to work with than point sources in terms of turning off a tap than point sources or pollution. But all of the sectors have reduced significantly, but non-point sources are still our most challenging source at this point. Per capita total nitrogen has been reduced by 80%. Again, we've seen increases in population, at the same time reductions in nitrogen load. Water quality has improved significantly. This is starting in 1974 through 2013. The red indicated when we were not meeting those chlorophyll A concentration targets, and the green when we have been meeting them. You can see that it took about 5 years once the wastewater treatment plants essentially turned off their tap, about 90% reduction from the wastewater treatment plants, before we started seeing improvements in water quality. Stormwater regulations, another big kick. Again, another little lag time, but we continue to see improvements there. These are El Nino years when we have very high concentrations of especially CDOM coming into our estuary, so light and chlorophyll concentrations are increased at that point. And we still have some problem areas that we're working on down here, but overall we're seeing a vast improvement in water quality. And in fact, water quality right now is as clear as it was in 1950. And of course, the ultimate test here is the seagrass, and seagrasses indeed have responded. This is our 1950s level, half of that about 1982. We've seen, this is the El Nino year. We saw when we're not meeting the chlorophyll A targets, we also lost seagrass during that time. So that's a very clear indication that our goals are aligned. Right now, our seagrass is expanding at about 1,000 acres per year, which is the highest rate that we have seen, which indicates we may be in a somewhat of a feedback loop here as we're continuing to see the clear water. In 1988, the voluntary effort from the public-private partnership also moved from being completely voluntary to also meeting regulatory goals. We do have a TMDL for Tampa Bay, and the public and private partners on the consortium have developed their own allocations. We know what the cap is. It's at the load that we saw in 1992 to 1994. But each one of the partners and the consortium have developed recommended allocations to all sources within the watershed, 189 different sources. This was a key management decision for that public-private partnership. Did they want to work together, or did they want to work individually with the regulatory agencies to come up with nitrogen caps, essentially? And they decided they wanted to work together to provide that, and essentially they wanted to drive the bus. And it's been a very empowering, I think, for both the public and the private sector to work through this process. The consortium developed and agreed to voluntary caps, which now have been accepted as allocations for the total maximum daily load and are being incorporated into permits. What this means, though, is that we're completely allocated. We don't have anything extra. So when we have a new source or one of our wastewater treatment plants has additional loads, we have to compensate that through the consortium, working together to try to develop projects that can reduce nitrogen to allow growth. And so that is, we're at a zero-sum game, as they say, right now. But so far it has been working very well. Some of the key elements in the nitrogen management strategy, I think a really important piece of this is that the target resource, seagrass and clear water, were considered worthy by both the public and from the scientific community. The community is willing to work together. We have an incredibly collaborative group working with the universities, working with the local governments, working with the regulatory agencies in the private sector. Science-based numeric goals and targets have been critical for helping with this. Multiple tools, regulation to get us started, public-private collaborative actions that have continued on, and most recently citizen actions. Long-term monitoring, critical. We would not be able to tell where we had been or where we're going without a long-term water quality monitoring program in Tampa Bay. A recognized honest broker to track, facilitate, and assess projects and progress. That is the function that our program plays. And assessment and adjustment. We've talked a lot about needing that adjustment piece, and certainly that will continue. And that is a very, very quick overview of Tampa Bay, and I'll turn it over to the next person.
All right, thank you.
Good.